All right, we are working a little bit more on some titration questions here. So a little bit of review. Neutralization occurs when you mix an acid and a base. The two products you always get are water and some sort of a salt. These are double displacement reactions or double replacement, whichever way you want to say it, means the same thing. So, cool little mole map with molarity added. If you've got grams of a substance, you divide by molar mass, you get it into moles. You use the mole to mole ratio, multiply by molar mass to get into grams of your unknown. Or, if you start with liters, as you often do in a titration problem, multiply by molarity to get moles, still use that mole to mole ratio, and you can do different things here too. Divide by liters to get the unknown concentration, or this one says divide by molarity to get liters of your unknown that you would need to add in order to produce a molarity. You'll see as we kind of get through some problems when you would use which situation. There's also a molarity triangle here, just to remind you. Molarity is moles divided by liters. If you want to calculate moles, you do molarity times liters. And if you want to calculate liters, you do moles divided by molarity. Alright, here's a sample little calculation. You've got 200 milliliters of HNO3. It's a mystery acid. You don't know the concentration. But you do know that you added 80 milliliters of a 0.5 molar base, and it was neutralized. So what must be the concentration of that acid? Well, first let's figure out how many moles worth of KOH we added. So we do 0.08 liters, that's just 80 milliliters divided by 1,000. Multiply it by the molarity. We're talking 0.04 moles of base we needed to add to neutralize. Well, it's a 1-to-1 ratio. For every 1 mole of base, you're canceling 1 mole of acid. So 0.04 moles of KOH means there were 0.04 moles of HNO3 in that solution. And we had 200 milliliters of it, so we're going to do 0.04 divided by that 0.2 liters, and we get our answer of 0.2 molar HNO3. Alright, practice writing some equations here. Write out the balanced equation between H2SO4 and KOH. So double displacement reactions, H switches places with the K. So we've got K, which has a +1 charge, SO4, which has a -2 charge, K2SO4, plus H is now with OH. So H2O. So now we've got to balance it. 2 K's on the right, we're going to need a 2 there. And we've got 4 hydrogens on the left, so we need a 2 there to make it 4 on this side. Circle the salt, K2SO4, that's potassium sulfate. How about nitric acid, HNO3, and sodium hydroxide? Na and H switch places. Now we've got NaNO3 and H2O. Now we've got to check and see if we're balanced here. We've got one of everything, we're balanced. Circle the salt. We made sodium nitrate. One more. H3PO4 plus NaOH. First two things switch places. We've got Na, which has a +1 charge, PO4, which has a -3. That's Na3PO4 plus HOH, H2O. Now we're not balanced here. We've got Na3, so we need a 3 here. And now we've got 3 H's plus another 3 H's, that's 6 H's, so we need a 3 there. Circle the salt, that is sodium phosphate. Alright, next page, stoichiometry calculations. Not exactly stoichiometry. These are more like neutralization reactions. A little correction there. Alright, so we've got to balance this first. 2, 3, 1, 6. We've seen this before. What if you've got 4 moles of H3PO4? How many moles of calcium hydroxide will it take to neutralize that? Well, we can do this one in our heads. 4 times 3, we're trying to get rid of 12 moles worth of H pluses. So we would need how many CaOH2s? We would need 6, because 6 times 2 is 12. Okay, so we can do it mentally, or we can set it up using the mole to mole ratio. So for every 2 moles of H3PO4, you need 3 moles of CaOH2. So 4 times 3 divided by 2, that comes out to be 6 moles of calcium phosphate, or calcium hydroxide. How about letter B? How many liters of this 2 molar calcium hydroxide would you need to neutralize 0.9 moles of H3PO4? So again, it's the same first step. For every 3 moles of H3PO4, you need, oops, I wrote this wrong, sorry. For every 2 moles of H3PO4, you need 3 moles of calcium hydroxide. Again, you're getting these numbers here from the front of they're the coefficients in the balanced equation. Multiply across the top, divide by the bottom, that's 1.35 moles of calcium hydroxide. Okay, so let's figure out here, using our little molarity chart, if we want to know liters, we can do moles divided by its molarity, so 2 moles per liter, and that's going to give us how many liters we would need to neutralize that acid. This comes out to be 0.68 liters. And then the last one here, it says how many liters of a 1.4 molar acid would it take to neutralize 500 milliliters of a 0.8 molar calcium hydroxide? Well, first we've got to figure out how many moles of calcium hydroxide are we trying to neutralize here. So 0.5 liters, I just divided that 500 by 1,000, times 0.8 molar solution of calcium hydroxide comes out to be 0.4 moles of calcium hydroxide. Again, we know for every 3 moles of calcium hydroxide, you only need 2 moles of H3PO4. Multiply across the top, divide by the bottom. We're talking about 0.27 moles of H3PO4 would be required to neutralize that base. Now, moles divided by the molarity will give us how many liters of acid we would need. 0.19 liters of H3PO4. Hopefully you're starting to see some patterns here. Number 5, write the balanced equation between HCl and NaOH. We've seen this one a couple times. We make salt water, NaCl and HOH, which is the same as H2O. Number 6, describe how you might experimentally determine how many moles of acid are in a 300 milliliter sample of HCl with an unknown molarity. Materials you have available: 1 molar sodium hydroxide, universal indicator. Okay, awesome. So let's do this. Put the 1 molar sodium hydroxide in a burette. Add 10 milliliters of the HCl sample to a flask and add some universal. It should be red. Universal is red in an acid. Add NaOH until the flask turns green. Then use the amount of base and its molarity to calculate the number of moles of base you added. Okay, it's a 1-to-1 ratio. 1 HCl for every 1 NaOH, so that's going to be equal to the number of moles of acid that were present in that 10 milliliters. So your last step is going to be take that moles of acid and divide by the 0.01 liters that you had measured out, and that's going to give you your concentration. All right. Number 7 is a titration question. So we're going to follow all the steps. How do I know that? I see an acid being added to a base, and I see the word neutralize. So step 1, write out the reaction. HCl plus NaOH makes NaCl plus H2O. Write what you know underneath each. We know we've got a 0.85 molar solution of the acid, and the question is, how many milliliters, or we can convert it at the end, how many liters of this acid would you need to neutralize 0.025 liters of a 0.48 molar solution of base? So first step, the one that you know more about, multiply liters times molarity to figure out 0.012 moles of NaOH were added. It's a 1-to-1 ratio. Every 1 mole of NaOH requires 1 mole of HCl to neutralize. So there must have been 0.012 moles of HCl required. Moles divided by the molarity of that acid gives you liters. So that comes out to be, I'm going to write it up here. Let's see, 0.014 liters times 1,000, the answer is 14 milliliters. That's how much of that molarity of acid would be required to neutralize that amount of that molarity of base, the NaOH. Now, number 8 is a titration, but it breaks it into 3 parts. So if you've been struggling, like, what the heck is going on? This is a good one because it breaks it down. It says after you added 100 milliliters of 6 molar hydrochloric acid to a beaker of sodium hydroxide, it became neutral. You had 600 milliliters of the base. So first, how many moles of acid did you add to the beaker? Well, we had 0.1 liters of a 6 molar acid, so that means that we added 0.6 moles of HCl. So how many moles of NaOH were in the beaker? Well, it's a 1-to-1 ratio. For every 1 mole of acid, there was 1 mole of sodium hydroxide present. So that means 0.6 moles of sodium hydroxide were in that beaker. And if there were 0.6 moles of NaOH and the volume of the beaker was 0.6 liters, that means the concentration of the base was 1 molar NaOH. NaOH. Mr. P is again really wanting to be in the video. He's a rock star. All right, number 9. You've got 150 milliliters of NaOH. If it takes 60 milliliters of a 0.75 molar H2SO4 in order to neutralize the solution, what must be the concentration of the base? Hint, write out the reaction first. You guys knew that already. So we've got H2SO4 plus NaOH. We know that that's going to make Na2SO4 plus H2O. In order to balance this, we need a 2 here and a 2 in front of the H2O. Next step, write out what you know underneath each. I've got 0.06 liters of a 0.75 molar acid that I had to add in order to neutralize that 0.15 liters of our mystery concentration of base. Liters times molarity, 0.045 moles of H2SO4 for every 1 mole of H2SO4, you need 2 moles of NaOH. Multiply across the top, divide by the bottom. That's 0.09 moles of NaOH that must have been in there. Divide by how much there was. There was 150 milliliters. That's 0.15 liters. The concentration of that base must have been 0.6 molar NaOH. So as you can see, it's the same steps every time. You write out the balanced equation. You write out your information underneath. The one that you know 2 things about, you multiply. How many liters times how many moles per liter, how many moles of that acid or base, depending on the question, do you have? Then you use the numbers out front to figure out how much of the other acid or base must have been present. And finally, you divide by the number you haven't used, which is, in this case, moles divided by liters to give you that mystery concentration. So keep practicing. The more that you do, the better you get.